Okay, want to welcome everyone to our Skimmer Sediment Basin Design webinar. This is our first attempt at a webinar, so please bear with us. I'm sure there'll be a little bit of a learning curve. We appreciate you all taking your lunch hour to join us, and I hope you find this informative. It will be pretty technical, and hopefully you'll find it useful in going forward as you prepare your Skimmer Sediment Basin designs. So first, a little about me. My name is Jamie McCutcheon. I am a 92 graduate of Clemson University. I founded CCAD Engineering in 1999 to do primarily private development-related site development work. In 2013, I invented the Marley Float Skimmer and founded SW Products. We rebranded SW Products as Rymar Waterworks Innovations in 2018. And I am a licensed professional engineer in South Carolina, North Carolina, and Georgia. So today, what we're going to try to cover is the few course objectives. So first, we're just going to help you understand what a skimmer is and why it is used, for those of you that are not familiar with skimmers yet. We're going to learn the fundamentals of skimmer basin design. We're going to go over some advanced skimmer modeling and go over a few software packages and how you would model the skimmers in those packages. And then we're also going to talk briefly about the benefits of using skimmers for post-construction use and how that can benefit your projects. So to start off with, I'm asked for a little interaction. So we have a poll about, that'll help me just kind of know about my audience and how familiar you are with skimmers. So if you would, it should be popping up, if you would just give me some idea of what your familiarity is with the product. So while that's being done, for those of you that are not familiar with skimmers, the way we typically are used to do ponds is we had a riser with a stone ring around it. Often had a low flow orifice at the bottom of the riser, and that riser was very successful in pulling in mud off the bottom of the pond. So skimmers came around about 15, 16 years ago, and they've been increasing in popularity with different states ever since. Skimmers are used to withdraw surface water from the surface of the basin. It allows more time for water to settle and mud to settle. Not water to settle, but allow mud to settle to the bottom and drain the basin from the top down to meet the surface withdrawal requirement of the EPA. The Marley Float Skimmer in particular takes in water from 8 inches to 16 inches below the surface, excluding trash and debris on the surface from entering the orifice. So we ended our poll and just kind of briefly let you know how that worked out. About 30% of you are familiar with skimmers and use them all the time. A majority, around 44%, have used them a few times, so somewhat familiar, and about 20% have heard very little about them or it's all new to them. So wide variety of who's here today. So most states have a construction general permit that includes requirements for sediment basins that's written, such as this is from Ohio. And it says, when discharging from sediment basins, utilize outlet structures that withdraw water from the surface unless infeasible. And most of them also include a note that says, that they believe that circumstances which is infeasible to design outlet structure in this manner are rare. So essentially, if that's in the state construction general permit, they're expecting you to use it on most sediment basins. So I'm going to do one more poll here as we get started and ask you, for those of you that are familiar with skimmers, does your state require skimmers? And that's a little twofold question. Does your state require skimmers? And if they do require, do they actually enforce it? So, if they require it and use it a lot, say yes. If they require it but don't really enforce it, you may use the somewhat button. Or no, if they're just not enforced at all, and you may not be familiar if they're required or not. While you're filling that out, this is a list of states that generally have surface withdrawal requirements. That is, should be pretty up to date. There may be 1 or 2 states that have been added to this or renewed their construction general permit since we compiled this list. But there are about 30 states that have surface withdrawal requirements. If you hit somewhat or no in the poll and realize that your state's on this list, you're probably in one of those that it's not very well enforced yet. Most states do not have any approved list of devices for skimmers. However, there are many Department of Transportations and even some local MS4s that do have an approved list that you need to meet certain requirements in order to be approved in their area. And based on the polling, we'll share the results this time, see how that works. But about 50% of you said yes, they're used in your state, and the other 30% are between somewhat and no. So, or excuse me, the other 50% are between somewhat and no as far as being used in your area. So we're going to touch on the very basic fundamentals of sediment basin design. So there are 3 fundamentals. They're volume, time, and flow rate. And so fundamental number 1, basin volume. The basin volume is based on the area flowing to the basin. Now, some areas refer to that as total area, some areas refer to it as disturbed area, and some locations don't tell you either way, so it's left up to the engineer. There are a couple of general standards out there. One is 3,600 cubic feet per acre flowing to the basin. Other states have a standard of 1,800 cubic feet per acre, so it can vary. And so, for example, if you had an 8-acre area draining to your sediment basin with the 3,600 cubic feet, your required volume is 28,800 cubic feet. Now, some areas also require basins to have a permanent pool volume or sediment storage volume that is below the outlet of that's controlled by the skimmer. It is important to use the required volume when you size your skimmer and not necessarily your actual volume to size the skimmer. And we'll touch on this a little bit as we go forward. So the next fundamental is dewatering time. So as we talked about before, basins work by allowing time for mud to settle. So the time needed to settle is going to depend on the soil type. So sands will settle quickly, but silts and clays may take much longer and often may not settle at all for weeks. But a general standard that we see in many areas is 2 to 5 days. Some areas call out a 2 to 7 day time, but you need engineering judgment to balance the need for extended times for certain soil types versus the frequency of rain events. So if your basin doesn't drain fast enough and it fills up and overtops, you can get a lot more sediment leave the site than it would over a slowly draining basin. So fundamental number 3 is flow rate. So this is easy to determine. So once you have the basin volume and you establish your dewatering times, then the required flow rate range is easy to determine by simply basin volume divided by dewatering time will give you your flow rate. So we recommend establishing a range of flow rates and a range of times. So you'll use the minimum dewatering time to determine the maximum flow rate and the maximum dewatering time to determine the minimum flow rate. Once this range is determined, you'll select the appropriate skimmer based on the manufacturer's specifications for how that skimmer flows. So for our example of a 28,800 cubic foot volume requirement for a basin, if you drained it in 2 days, you'd use a skimmer that flowed at 14,400 cubic feet per day as your maximum. Or if you extended it out to 5 days, you'd use a skimmer that drained at 5,760 cubic feet per day as your minimum flow rate. And it is important to note a lower flow rate will often result in a smaller, and if it's smaller, it's typically less expensive skimmer. So that may be of a benefit to your contractor and client. So to emphasize the importance of flow rate, not just skimmer size, I want to refer to this chart. This was taken from some testing that was done by TRI Environmental. TRI was engaged by the state of Georgia when they were updating their Green Book, and they tested a wide variety of skimmers. And so for this, I'm going to focus on 3 different 3-inch skimmers. And you'll see two of them. Their test tank, it goes from 0 to 4 feet deep. So you got 0 at the bottom, 4 feet at the top. And so two of the skimmers start out flowing around 37 gallons per minute, and one was nearly double that at 70 gallons per minute. As the depth in the tank increased from 1 foot to 4 feet, you'll see all three skimmers had an increase in flow rate of about 25%. And again, two skimmers had a flow rate similar in the 47 to 53 GPM range, so that's fairly close. But one, again, was nearly double at 90 GPM. So the point is that it's critical to specify flow rate, because if you just specify a skimmer size and not the brand or type of skimmer that is based upon, you may get a flow rate that's a lot higher or a lot lower than what you actually need to meet your requirements. So this is our skimmer flow rate chart from our testing. It has all of our different skimmers and orifice configurations up to our 4-inch skimmer. And you can see that all of them have a slight increase in rate from 0 to 4 feet. So often skimmers are thought about as constant flow, constant head devices. Testing has shown that's not entirely true. There's generally about a 25% increase in flow rate as you increase from 0 to 4 feet of depth. So just to give you an idea of some of the different standards out there, we've compiled a list of different states that we are familiar with. We're based in South Carolina, so we've included it. North Carolina and Georgia are neighbors, so we've included those two as we have a lot of familiarity with those two states. Ohio has been a popular state for our product, and then Kentucky is a state that is just coming on board to start requiring skimmers. So if you look at basin volume, you'll see South Carolina at 3,600 cubic feet, while North Carolina, Georgia, and Ohio all have 1,800 cubic feet requirements. North Carolina defines that as disturbed area. Ohio defines that as total area, and then has an additional requirement of 1,000 cubic feet per acre of disturbed area that is for sediment storage or a permanent pool that's not drained by the skimmer. And Kentucky, it is required to calculate it. It's based on the soil type, and you're required to calculate the area needed based on your soil type. Surface area is 325 square feet per CFS for a 10-year storm in South Carolina and North Carolina. In Georgia, it's based on a 2-year storm, and if you run the math, it comes out pretty similar to the 10-year storm requirement. Ohio does not specify a surface area, but has a maximum depth of 5 feet, and by doing so, ensures they have reasonable amount of surface area for the basin. And then again, Kentucky requires it to be calculated based on the soil type and a basin ratio. The principal spillway would typically include the skimmer and the riser structure, and it may also include any other orifice or openings in the riser if you have any. But that varies from a 2-year requirement to a 10-year requirement depending on the states. States have a requirement for emergency spillways for your overflow in larger storms. Again, that's ranges from a 10-year requirement in North Carolina, 25-year in Georgia, Ohio, and Kentucky, and 100-year in South Carolina. And then where skimmers are required does vary quite a bit. In South Carolina, they're not technically required unless you have 10 plus acres going to a basin. However, I will caveat that to say if you have a sediment basin design and not a sediment trap design, which the trap would typically be a rock outlet, not a riser structure, then they do typically require skimmers to be installed. In North Carolina, they're required on most basins. We've seen some very, very small basins in North Carolina that are even hard for our smallest skimmers to hold for 2 days. They're so small, but they're required there. In Georgia, they're preferred. They still allow perforated risers and stone at the state level, but some MS4s in Georgia actually can't require the skimmers. Ohio, again, it's a 10 plus acres. In Kentucky, it's 5 plus acres. But again, any sediment basin that has a riser structure configuration typically is required to have a skimmer, even if they're smaller than this. It's only if it's a sediment trap with a rock outlet or some alternate outlet that you're not required to do that. And then one of the most important things is dewatering time. So dewatering time ranges from typically 2 to 5 days to maybe 2 to 7 days in Ohio. Georgia has no standard specified, so they leave it up to the engineer of record to determine based on the soil type for that specific project. And then in Kentucky, it's required to calculate it as an 80% trapping. I will note that South Carolina does have an option to calculate it at 80% trapping, and in some cases does not require the 2 to 5 day time be met under that scenario. And I'm not certain if North Carolina or Ohio require that, but in most cases I see they want the 2 to 7 day time frame or 2 to 5 day time frame. I do have our question and answers open. So as we go along here, if you do have any questions, please feel free to type them in. I got a note that the requirement for skimmer on basins over 20 acres in Ohio is not correct, and that there's no specified drainage area for skimmers. So I'll have to double check that and see, but I do know we work closely with the Cleveland area and the Columbus area and Ohio EPA on coming up actually with a Ohio specific design tool, but if I have that incorrect, I apologize. So to help you with your basic fundamental skimmer basin design, we have created two simple Excel design tools. These are both available on our website, and they're free to download, no login, sign up required. And so we'll go through those pretty simply. First one is for a skimmer basin that does not have a permanent pool. So we give you your date, project information, company information that you plug in here. Your basin description. We give you two other lines just in case you feel the need to say something else, as engineers sometimes do. We give you a place here for you to calculate your required dewatering volume. You can plug in your acreage to that basin and then your volume required per acre for your area, just to give you a check to make sure your calculated volume and your required volume are within a reasonable amount. So then we give you a place to plug in your maximum time to drain and minimum time to drain. Again, 2 to 5 days is a typical, but that may vary by your area. Your pond depth. Now your pond depth would be the depth that is controlled by your skimmer. So if you had depth above your riser or areas that are not controlled by the skimmer, you would not include that. Or if you have depth that's going to create greater volume than your required volume, you would not include that depth. Your top length and width and your bottom length and width. Now we recognize that there are almost no basins that are rectangular or square. So please use your engineering judgment to adjust these numbers so that your calculated pond volume comes out to within a reasonable, we recommend at least within 5%. In this case, I think I'm within about 1% of your required dewatering volume. And again, we recommend, and a lot of areas recommend and require that you use the required dewatering volume, not your full basin volume. The reason being, if you have a basin that's going to be a multi-purpose basin that's going to convert to your final detention pond, the volume required for that pond could be much greater than your sediment storage volume required. It could be 2, 3, 4 times as much. And so if you base your skimmer size on that much larger volume, you're going to find that you're going to drain out the required volume in less than the time required. So you'll actually use a bigger skimmer, drain it too fast, and you won't be meeting your requirements for settling time. So once you plug in this information, and I understand you cannot read this chart, but this just shows you we have all of our skimmer configurations on here. And at the bottom, we've created a skimmer report page tab. So you click on that tab, and it'll take you to a nice, neat one-page report. It'll give you your engineer and company information up top. It'll include the required information, required dewatering volume, your calculated pond volume, so you can easily compare those two. It'll calculate your minimum flow rate for your maximum time to drain and your maximum flow rate for your minimum time to drain. And because it is our tool, it'll show you which of our products are suitable for this basin. And as a blow up here, you can see that depending on which skimmer you pick, you could have a drawdown time of anywhere from 10 hours to almost 2,000 hours. And based on the specified range of 48 to 120, there are actually 5 different skimmer orifice configurations you can use to meet that requirement. And then you can pick which one of those in your engineering judgment is best for the site. So if you decide you'd rather drain it as fast as possible and meet that, you would go with our 3-inch skimmer with a 3-inch orifice. Or if you want to go as slow as possible, you go down to the 3-inch with a 2-inch orifice. And that's one of the advantages of the skimmers that we produce is if you pick the 3-inch and decide it's draining too fast or too slow, it's very simple to change that in the field with a simple orifice configuration. We have also created sediment basin details. So our basin details are also available online for free. They're in CAD and PDF format. We have 4 versions. We have a basin detail for a temporary basin with just a pipe through the dam with no permanent pool, or we have a riser configuration, with no permanent pool. They both give you the basin criteria. So you've got a length to width ratios that you can establish based on your local requirements, volume requirements, surface area requirements. Again, gives you a place to specify your minimum and maximum dewatering times. And so when it goes through the review process, you've specified this on your plans. And then down at the bottom, we give you a data block. It's got space for 2 basins, but can easily be expanded to more. And that includes your drainage area. So that'd be your total area to the basin, your disturbed area to the basin, your Q, this may be a Q10 or Q2, depending on your MS4 or state requirements. The basin volume, again, your required versus your provided, and a simple way here to show that you're meeting your required volume, but also designing your skimmer based on your required volume. Surface area required and provided. Outlet invert information, barrel pipe size, spillway, elevation, and width. And here's the important parts here: the skimmer size, skimmer orifice diameter. Most manufacturers have different orifices available for different skimmer sizes. The skimmer manufacturer, you can go ahead and specify a brand that you based your sizing upon. Is an equal allowed? Yes or no? Now, most of the time that is going to be yes. There are some instances where you may say no. You may have a quantity control requirement, and it may be very important that you have a very precise flow rate to meet that. But in most cases, that's going to be a yes. And then again, based on your minimum and maximum dewatering times, you'll establish your minimum and maximum flow rate. Now, the big advantage here is once this plan is approved and it's been through the review process, the reviewers approved that range of time and that range of flow rate. If you get to the field and the contractor decides they do want to use a different skimmer than what was specified, it's a simple shop drawing review to confirm that that skimmer falls within the flow rate that's already been approved, rather than having to do a full plan review again. Now this in most cases, but not all. So the other tool we have is very similar tool. The only difference is it includes a permanent pool. So this one is based on, started in Ohio, where they have a permanent pool. It gives you your required sediment storage, and in this case it's typically based on disturbed area, and then your total drainage area for your required dewatering volume. So you specify those, or you can include those up top as a check. In this case, you'll see, our drainage area that we're basing the basin on, volume on, is the same, but the volume per acre is half. So you've got a much smaller required volume for your pond. Again, the same inputs. Again, the pond depth does not include that permanent storage volume. So it's basically from your invert of the pond up to whatever height the riser is going to serve. And you calculate that volume again, make sure it's within reason, close to the required volume. You have the same report page. The difference is you do include the required sediment storage volume, so you can do a check on that portion of your plan. But Basically everything else is the same as our other tool. You'll notice, we had the same size area, so the same 8 acres, but in this case, you've got 2-inch skimmers that would be acceptable, which are a little bit less than the 3-inch skimmers, but you still have one of the 4-inch skimmers that meets that range. So, it may vary in the sizes that you can pick from. And again, our basin detail, this is the permanent riser configuration detail for one with a permanent pool. Sediment basin criteria is pretty similar. We've added a sediment storage volume required in the chart. We've added some tabs here for the sediment storage volume required and provided. And then we've added our dewatering volume here as well. Got 2 questions that popped up. I'm going to try to answer these as we go. One was, will participants be able to receive a copy of this webinar? Yes, I forgot to mention that at the start. We are recording this webinar. It will be available on our website and through our YouTube channel. So you will be able to get back to it if you'd like to refer back to it. Then I also had a question about whether a different type skimmer than that approved is allowed without additional approval. And I will say that is really a MS4 by MS4 criteria. I'm aware of certain MS4s that are very, very picky and will only allow the skimmer that was approved to be put in the pond. And I'm aware of other MS4s that are very, very loose. And as long as they see something floating, they're happy, and everything in between. So, I believe we have a good number of regulatory folks and reviewers on with us today, or at least had signed up. Hopefully they were able to join. And so when we get to the end of this, we may get some feedback for some of those folks to see how their different areas are done. But I do know that just here in South Carolina, we've got probably 6 or maybe up to 10 different MS4 within our area. And that particular question varies widely just here. So unfortunately, there's not one certain answer, but I would say that if you get it approved on the front end and you've approved that flow rate range versus a specific flow rate, then I would think it would be simpler to make a simple approval or simple skimmer change versus if you design for a very specific flow rate based on a very specific skimmer and it wasn't certain that that range was appropriate. Hopefully that answered the question. So, couple of pictures here I just want to show you for those of you that haven't seen skimmers installed. So this is a relatively new installation. This is a Marley float that's being put in. What I want you to notice is this skimmer pad. So the details typically call out for this to be a depressed area. And this is a good picture to show you why. What happened, the contractor graded this. They looked like they did a pretty good job. They tracked the slopes. It hadn't been seeded and matted yet, but that's probably coming. They've got their baffles in, which is good. They've keyed those in. But then they installed the stone for the skimmer on top of the graded area. And as you can see, it's already rained once, and you've got permanent ponding, or relatively permanent. It may infiltrate, but this looks like a pretty clay red soil, so likely to hold there. So had they excavated this out a little bit more and set the stone down level, the skimmer would be sitting down another 6 or 8 inches, and this area would drain down to that skimmer pit and keep more of the bottom of the basin dry. So just one thing to look for. It is typically shown on the plans that way, but often we see in the field it's not done that way, especially in areas where skimmers are new. Contractors aren't familiar with that. They find out after a few jobs that it's very hard to get grass established in the bottom of these basins, and they can become mosquito factories during the summer. So we do recommend to put the skimmer pit in so to drain as much of that area as you can. This is one of my favorite or least favorite pictures, depending on how I want to look at it, but this is definitely how not to install a skimmer. This was provided by a reviewer that sent it to me and said, we think something's wrong here. Typically you want the pipe that's connecting the skimmer to the outlet to be at least 1.5 times the height of the structure. Obviously, this one looks like it's about 2 feet. It's interesting, the outlet configuration. They've got an opening here on the side, some sort of a valve or cover that is left open so it would drain down. They put these, ring of riprap so close that the skimmers, lifted up. So just lots of things that are wrong with this picture, and hopefully you won't see these on your site. And then one other picture, maintenance is required. These are not maintenance free. This particular one actually had a big root ball growing inside of it and was greatly restricting the flow. So, tip of the day, if you see vegetation growing out of the skimmer, you might have a problem, might need to do some maintenance. Okay, so at this point, we're going to jump into our advanced skimmer modeling. We've been through the basics, and kind of hopefully now you understand what skimmers are, kind of what their general function is. But in some areas, it is desirable to do more advanced modeling. As you saw in Kentucky, they actually require you to calculate 80% trapping efficiency. So how would you do that with a skimmer? And then we're going to talk a little bit about post-construction use. And so we're going to go through some modeling of some software that will do post-construction modeling at pre versus post rates. So before we do that, I'm going to jump into one more question that'll help me. So what is your role? If you work with a state, county, or city agency, or if you're a consulting engineer, or if you're a contractor, or if you're an other, if you may be a distributor that's joined us today, or maybe you're work with another vendor or manufacturer of erosion or stormwater products. I'd like to get just some idea of who all we've got listening in. All right, we've got just a few more to respond. I'll give it another couple of seconds before we jump into the modeling. So, all right. So I'm going to end that poll, share the results. So we have about a third of you are with city, state, or county agencies, or maybe some DOTs. So, again, please correct me if I say something that does not line up with your state. Over half are consulting engineers or designers, and we welcome you, and hopefully you find something useful today that can help you in your process. No contractors on that we're willing to admit it, at least. And then we've got some others that I know we've got a couple of our distributors on, as well as a few other people today. So SEDCAD. So we're going to talk about the SEDCAD software here. SEDCAD is a software program that's used primarily to calculate trapping efficiency. It is not great for pre versus post discharge rates. It can do it, and you can use it if you like, but it's not. It's got some issues with it and that have been identified. So you're going to use. It's very similar to other software in calculating those. You're going to build your basin with the capacity here. You're going to determine your sedimentology, some different settings there. It'll calculate your peak in and out rates and your peak runoff volumes, peak elevation, and your dewatering time. Again, this calculation, see that dewatering time is way less than the 2 days, but we've hit a 91% trapping efficiency. It'll also calculate your sediment concentrations coming in and coming out. So when you do this, I'm not going to go through all the details of SEDCAD. If you're not familiar with SEDCAD and have more questions or would like some more detail on that, please reach out to me directly. I'll give you my contact information here, and I'll be glad to go through this in more detail. But you're going to enter your watershed data, so your drainage area, your time of concentration, and your curve numbers. That'll build each watershed. It has sedimentology data factors, so a K, C, and P factors that relate to the soil type, erosivity of the soil, etc. Length and slope. You can actually put in your soil type and your soil gradation classifications. And then you enter your basin information. What's important here in order to have data points to put in the skimmer information is set this stage increment to 0.10. So in this case, we built our sediment basin. So we go from 1040 all the way to 1056. That's a really deep basin. and we're setting our stage increment at 0.10. So you're going to build your outlet structure. So you'll have a perforated riser, which will be typical. So that's just your riser structure. By that, you'll define the diameter or circumference at the top of the riser. And then next, instead of putting in an orifice, which would be typical, you're going to put in a user input discharge. Sorry, and so when you do that, it'll come up with this table, and you can user define your discharge at each elevation. Oops, sorry about that. So you put in the discharge rates based off of your manufacturer's information for the skimmer. So for our skimmers, we list the discharge rate from 0.1 feet to 4 feet, which is the depth of the test tank that we did our testing. And we listed in cubic feet per second, cubic feet per day for the skimmer with no orifice and with each orifice configuration provided. So all that's right on the detail. So basically take that off the detail, plug it in. SEDCAD will calculate between, so you don't have to calculate each tenth. It'll interpolate for you. Once you get up to 4 feet, then you've got to make a decision whether you maintain that flow rate or extrapolate it out. In our testing, and if you remember seeing the graph, most skimmers are starting to stabilize at around the 4 feet. So really just use your engineering judgment, whichever one you prefer. And go, in this case, we just plugged in that depth or that flow rate to continue on through up to the peak of the pond. So when you do that, SEDCAD will run a sediment graph and will calculate your inflow and outflow of sediment. One thing that's very important to realize here, SEDCAD does not take into account the surface withdrawal effect. SEDCAD doesn't know how to do that currently. So it assumes that water is coming through the entire water column from top to bottom. So the actual trapping efficiencies through the use of a skimmer will be higher than what is calculated. And so, as we mentioned before, South Carolina and Kentucky require 80% trapping efficiency during construction. So when we ran SEDCAD on this particular example, we got a 91%. So we checked the box, and so our basin meets the design requirements. Now I will mention in some areas, depending on the MS4 and depending on the reviewer, you may hit a 77, 78, 79% trapping, and you keep trial and error with your pond, and it's just hard to get it up to 80%. We have been successful in some cases with identifying that SEDCAD does not factor in surface withdrawal, and therefore is reasonable to assume it is underestimating the trapping efficiency based on that fact. And if that's explained to reviewers, they may be willing to forego meeting that 80% if it's reasonable within your engineering judgment that you've hit a percent high enough that if you factor in the surface withdrawal, you would actually get to your 80%. So hopefully that was helpful on SEDCAD. Again, we're just touching on this just to kind of get you an intro to advanced modeling today. If you need more detailed information, we'll be glad to help with that. HydroFlow is the next one on the list. HydroFlow Hydrographs is a very popular software package. It's now actually included in Autodesk or AutoCAD's Civil 3D program. And so we're going to go through a specific site we did in the city of Greenville. Now, in this case, the city was requiring quantity control during construction. So it's a little bit different basin design than just your just worrying about sediment control. So this area was about a little over 5 acres, had about 3.4 remaining undisturbed, and about 2.2 that were all draining to this study point, coming down through this site to a study point. The study point was across a little side road. There's no drainage on our side of the road, and we were trying to make sure that the discharge to the road was at or below pre-development levels from a liability standpoint, and just not harming or eroding the area. So pre-development, we had 5.5 acres, had a curve number of 59 and a time of concentration of about just under 20 minutes to calculate our pre-development rates. Post-development, the undisturbed portion was the same criteria. The disturbed portion was 2.23 acres. We used a curve number of 86 to simulate a disturbed bare soil clay condition. Had a time of concentration of 7 minutes for that. And so we built our basin. This goes from 0 to 4 feet deep. As we built our basin, we put in data points so that we could plug in the skimmer flow rate and build that flow rate curve into the outflow. So we see we've got a 0.1, 0.3, 0.5. Now, we did this as an example. You may decide that it's not critical to put in every data point and skip and just put in every foot. You know, whatever you may prefer and you feel like is reasonable there, but we did this to provide the most accurate flow rate information we could. Again, our skimmers provide, our details provide those flow rates at every 0.1, 0.3, and then every half a foot up to 4 feet. So then when we build our outlet structure, we have our culvert A, which is the outlet pipe. In this case, we have an orifice C, which is actually a 6-inch hole on the riser structure. That's just under 2 feet above the bottom of the pond. We have a riser structure that is just under 4 feet, so 3.6 feet tall. And we actually had a rectangular weir in the riser structure at 3 feet above the bottom. And then where we put in our skimmer flow rate is this user-defined column. So again, you've got your stages identified here, and then you take the data directly off the detail, plug into user-defined. If you go over 4 feet, you can again extrapolate it or just use the same flow rate. I think hydroflow actually requires you to go up slightly, so you may go up, you know, 100th or 1,000th of a CFS to meet that requirement in hydroflow. If you're going to extrapolate it, we recommend you look at the last 3 data points and extrapolate it from there. Or if you look at our Excel spreadsheet, we actually have a flow rate curve that you can utilize and plug it in, and we'll extrapolate that for you out above 4 feet. So once you build the structure, it looks like this. Normally you'd see a low flow orifice at the bottom. In this case, we don't have that because that's our user defined. We have our 6-inch hole just under 2 feet off the bottom, and then our rectangular weir about 3 feet, and then our riser at 3.6 feet. And so if you look at your stage discharge hydrograph, this first area is your skimmer, and then you've got your 6-inch orifice kicking in, your rectangular weir kicking in, and then the spillway kicking in. So you can see how those change. And then just identify your skimmers, a very small portion. So the green line here represents the skimmer flow all the way up to 4 feet of depth. If you look at the flow table, you'll see the only thing flowing is your user defined to simulate your total flow, and the other orifices kick in as they get to those elevations. And so if we looked at our 2-year flow, our pre versus our post, for our pre, we had a 2.4, 2.33, 2.34 CFS, and post, they actually let us have a just about 0.15 CFS increase in our 2-year flow. Our 10-year flow rate went from 9.5 CFS down to 9 CFS, so we're reducing it by half a CFS. And so the reviewer in this case was willing to allow us a very slight increase on the 2-year and show a reduction in the 10-year. So then we looked at, at least for this presentation, we had done this basin in SEDCAD and gotten to our 80%. And so we weren't required, because of doing that, to hit our 24-hour time frame. But if you look at, our 48-hour time frame, this is in South Carolina. So if you look at the hydroflow hydrograph, the pond really doesn't fill up to about the 12th hour of your storm. And on your time, you've basically let everything out by 29 hours. So, even if you didn't factor in the 12-hour fill-up period, you're much less than 48-hour time frame to drain out. In reality, you're only about 17 hours from your time to drain out. So we took a look at it and we said, well, our basin's full because that's up to the 961.6 elevation. So it's going over the top of the riser already. So any more, it's going to increase our peak rate. We're not be able to go up more there. So we'd have to increase the size of our basin. And so we, as an example, we said, what would happen if we had to meet our 48-hour time frame? So we plugged in data for a smaller skimmer, and by doing so, extended the dewatering time out to 66 hours. So even if you don't start till 12, we're still over that 48-hour window to dewater the basin. So we're now meeting that requirement. We checked again, it's basically getting up to the top of the riser, but it's going a little bit higher on the riser structure now than it was before. And we don't meet our minimum freeboard anymore, so we've got to at least raise the dam to meet that requirement. But then when we look at our 10-year flow rates, our pond's gone from 9.5 free now to almost 11 CFS post. And it's a little counterintuitive, even though we have reduced the skimmer size and we're now letting out less water by the skimmer, because the pond water is getting higher in the water's getting higher in the pond. It's higher in the riser, and you've actually got a fairly significant increase in overall flow from the basin. So the basin went from 2.6 CFS before to 4.6 CFS discharge right now on just the reservoir. Just got one other question too. It says, how is this accounting for the constant head with the skimmer? I'm not, and I missed that question for a second, so I'm not sure exactly when you answered it, or asked it, but we're using third-party tested flow rates for all of our skimmer flows. So the third-party testing has shown that the constant head with the skimmer does not necessarily result in a constant flow rate. And so any flow rates that I refer to in this presentation for their skimmer are based on testing that was been done by TRI Environmental to confirm the actual flow rates for each skimmer and each skimmer orifice configuration. So we'll go through one more software package. HydroCAD is very similar to HydroFlow. We did a project in the Charlotte, Mecklenburg County area and did our preliminary meeting with staff there, and had a comment from the reviewer that they didn't really like HydroFlow and for some reason preferred HydroCAD. So we said, hey, let's use HydroCAD and give the reviewer what they would like. So we did that, and really found out that HydroCAD is very similar as far as how it works and how it's set up. One of the key differences between HydroCAD and HydroFlow is HydroCAD is a smaller company, a little more nimble, and has included many proprietary products in their software package. So we have a agreement with HydroCAD, and they included our skimmers in there. So when you build your riser structure or outlet structure, you've got your riser as your primary. And then if you want to put in your skimmer, rather than having to plug in each data point, you click on this Load from File button. When you do that, it'll pull up a list of proprietary products, and Marley Float is one of them. Now, these are currently our older models, which we're going to talk about here in just a few minutes, but the newer models will be added to it soon. And you just pick the one you want to try, and it'll plug it all in for you. It's got a button where it can extrapolate it, above 4 feet if needed. So it does the math for you. So it makes it nice and easy. So it's really convenient when you're doing trial and error, trying to find which skimmer configuration is going to meet that sweet spot of pre versus post flow rate. And it also factors in that flow rate curve in doing that. Again, it has a way to confirm you're meeting your time frame. So you go to your node report. You'd have to edit your settings to increase your time frame from 5. It typically ends at 24 hours. You'd stretch that on out. In this case, we went to 120 hours. And then you can look at your hydrograph again and see that the time frame is similar to that 66-hour time frame is what this one was based on. So again, just touching base on these products just to give you a feel for how to incorporate skimmers into them when you need to look at a pre versus post rate, which would mainly be during a post-construction application or the rare circumstances where quantity control is required during construction. So speaking of permanent, we're going to talk about a little bit about permanent use of skimmers. So I'm going to just give you two quick examples. So skimmers can help with maintenance. So this is a pond that was in really rough shape. You see all the trash and debris that's in this thing. Oops. And we helped this client clean this pond out. We found out after we got it cleaned out that this picture on the right is a good one to look at, but there was a low flow orifice that's 5 feet below the level of muck and mud currently in the pond. And you can kind of see the shaded areas. This was the old holes in the riser. We redesigned the structure. The pond actually had extra volume, which is, I know was rare, but it had it in this case. And we redesigned it and incorporated a skimmer into the final design. And you can see the different phases. We monitored this thing every month for a year. We still monitor it about every quarter to make sure it continued to work well. The best example we have is about a year or so after the skimmer had been in, the client was now doing maintenance on this pond. Before it was a jungle, but they're now actually cutting it on a regular basis. But they had cut the sides of the bank, but had not gotten all of the debris out of the basin. And they had a 5-inch rain in just a few hours. And so all of the debris got flushed down into the bottom of the basin, and all this junk was in there. But you see the Marley float did drain down and was able to drain it even with all the debris and junk there. It didn't clog up. It was the rarest time where actually water got to the top of this riser. This riser's about, I think 12 feet tall or so. And remember, it's got another 5 feet down below. So in the event a low flow orifice did get clogged, it would be a bear to get to it to unclog it. And so, in the event the skimmer did clog, at least you can pull it over to the side. Now, in this case, they forgot to attach their maintenance rope to it to make it easy to pull to the side. But typically you'd have a rope, just pull it over, be able to check it and unclog it if it had any debris. We had another site in Charlotte area where this was an apartment complex, had a really old pond that had not been maintained in a very long time. We helped them clean it out, found it had a head wall down here, it had a pipe down at the bottom that when we started here, the mud level was up to nearly the top of this head wall. It took us a while to even find the outlet just because it hadn't been maintained. But we got that cleaned out, and we added some riprap around it. But it was in a natural area, and every time it rained, they get all this trash and debris go down to the outlet hole and clog it up. So even I think it was a 6 or 10-inch hole to start with there, kept clogging. And when its pond would fill up, it'd be nearly impossible to get down to it to get it unclogged. And so what we did is we came in and we redesigned it. We put in a riser structure. We put in a skimmer. We put in the maintenance ropes to be easy to get to in the event it did clog. In doing this, we also applied for a stormwater fee credit for this client. And Charlotte has a pretty high stormwater utility fee. It's about $2,000 per impervious acre per year. And they also have a very aggressive credit program. And we were able to get this client nearly a 95% credit. So it resulted in about $25,000 a year savings, which easily paid for this construction in just a year or two. And now they've got a major benefit to having the skimmer, plus it's much easier to maintain. We monitor it on a regular basis. It is in a natural area. It's a natural spring coming to it or stream coming to it. So it does stay wet from time to time if they have any kind of rain. But it is working. You can see here the riser has all this debris and junk up to the top of it, but with the storms, it still does drain down. And again, you've got the original pipe down at the bottom still doing some detention and not clogging, and with the trash rack and the skimmer, that pipe's not getting clogged. So very successful use of a skimmer for permanent maintenance with the added benefit of stormwater fee credits. So a little bit now as we wrap this up, got just a few more minutes of your time we'll take up, but I just want to make you aware of our website. As we mentioned before, our website is rymarwaterworks.com. We have a number of resources and tools there for you for free. We have our design tools. So we have our design tool for a standard basin that's dry. We have we used to call it the Ohio design tool. That's now been updated to a permanent pool. We have comparison charts. You can see how our skimmers compare with some of the competitors. We have details in PDF and CAD and installation instructions. And if you scroll down this page, we have our basin details. Again, all these are free. Just log into our website. You don't have to do anything in order to get them. So this is our typical detail. This is our new design. We're going to talk about it briefly here in just a second, but a couple of changes. We've shifted it now, so all the weight is on this bottom portion here, and we've got a float above. We also have a customized flexible bellows type coupling here. That will flex about 135 degrees, but it also stays relatively rigid to keep the skimmer in place out in the basin where you need it to be. Again, all of our skimmers include, all of our details include the flow rates. And each of our skimmers have, we call it an orifice plate. I'll show you a picture in just a second, but each of these plates has different orifice sizes. So every one of these skimmers that we make will have anywhere from 3 to 5 different configurations. So it has a wide range of flow in each one. So the other thing that's a little bit different about the Marley float is its construction. So it's an HDPE product, polyethylene float and stainless steel or aluminum fittings. So it's will not rust, and very UV resistant, and honestly it's virtually indestructible. It's extremely durable product. We've had one get blown through a dam in a hurricane, and they picked it up from 100 yards downstream and put it back in, and it worked fine. It is designed to be part of the permanent outlet structure, and just has one pivoting part, really no moving parts to get stuck or any problems with. We mentioned the stay level, so hopefully you can see this video, but this is our new design. It doesn't have the skirt on it in this case, but just showing you how no matter what you do to it in the pond, it's going to always come back and stay level. Always going to float right and float correctly. Even side to side, will come back. So in the past, we'll admit we've had a few issues with products tipping, and that has been completely resolved now. This product will not tip and always stays level. Another unique part of the Marley float is this debris shield. So we switched. We used to have a plastic guard on the inside. We now have a fabric guard on the outside. So this is intended to force water to come from just below the surface, typically as low as 4 inches if it's here at the middle, but really, about 12 inches below surface is ideal. It traps floatables in the basin, and it increases the sediment trapping efficiency with this design. And mud and debris do not get to your outlet. Also with the design, it will work in mild frozen conditions. Now it probably won't work if you get a foot of ice, but if we get 3, 4, 6 inches of ice, our intake is far enough below the surface, it will continue to work. We mentioned the orifice plate. So in this case, you can see here a little bit better. We've got this little screw kind of nub in the middle where this hole fits. And so it makes sure that each orifice as it rotates is centered over the outlet pipe. And so in this case, it's our 2-inch skimmer. So we actually have a 2-inch if you take the orifice out, and you have a 1.5, 1, 0.75, and 0.5 all in one product. So wide range of flows, very easy to change in the field. And again, all of our flow rates are third-party tested. We're excited. We have our large models coming soon. So this is our new custom float. We had to, make sure that we had a big enough float to make sure our large models would not sink. We used to use 2 different floats. We've gone now to just one large float. We've got built-in handles, make it a little bit easier to carry. It's very, very simple installation. And we've had some people ask about using it for permanent use. And do I want that big orange float in my pond? Well, now we have the ability with our custom float, we can actually do custom colors. So we can do a green or dark blue or black or something that'll blend in and not be quite as noticeable in the pond when you, if you want to have it for permanent installation. We just need a little notice in order to get those made, but just letting you know it is something that is available. And we expect we're doing our testing next month in middle of May. Should be testing this one to verify our flow rates for our 6-inch and 8-inch models. We expect our flow rates are going to be substantially higher than most other skimmers. We're approaching, in some cases, most skimmers stop around 1 CFS. We're expecting to get at least 1.5 to maybe as much as 2 CFS out of some of these skimmers, just the way the hydraulics are set up. And so, you know, if you have a really large basin that needed 2, 3, or more skimmers before, you'll be able to reduce that with ours. So I forgot to mention one thing before I go to other Rymar products. Back up. As far as pricing goes, we usually get some questions about pricing. I will say our products are very price competitive because each of our skimmers typically covers 2 or 3 of the competitors' skimmers. You know, it depends on which product you're comparing it with, but I'll give you an example. Our 3-inch skimmer retails for $795. It competes with anything from a 2-inch skimmer up to about a 4-inch skimmer. The other models, which would range from $700 up to about $1,300. So we're kind of right in that middle range, depending on which one you compare it with. But if you have specific questions about that, our pricing, our retail pricing is available on our website as well. So as we wrap up here, got a couple more minutes. If you can hang on, we've got a couple of new products we're debuting. One is our VersaWaddle, our standard. So this is a product that's foam filled. It's basically a filter fabric wrapped around foam, designed to be driven over. So it's ideal for construction entrances and access points where you need access across a curb or sidewalk to put in. So that's a new product that's just now coming on. And the one we're really excited about is our VersaWaddle hard surface model. So this product was developed out of a need where we had water continuing to bypass catch basins. In this case, this is a subdivision where the final asphalt surface is not put in. So water gets in the asphalt and shoots straight by the boxes, and you can see downstream, you've got a large buildup of debris that's actually off-site near a stream. And so it just wasn't getting into the boxes. So we put these in. These are our prototypes. We actually are changed the design a little bit, and they're now orange to be a little more visible. Little quick video here to show you how well they work. You can see the water coming down. We're trapping the sediment, and then we're kicking the water over the curb into the catch basin. But you can see a good bit of the sediment's being trapped, and the main purpose is, you know, direct that water into the catch basins, and so it doesn't bypass while you're doing that trapping. Simple maintenance, just a little shovel to pick them up. And then we said they're designed to be driven over. You know, most other products in this category, excuse me, gets hit by a dump truck, they're done, they're toast. Now you've got busted rubber and material or straw all over the place. Ours are designed to be driven over repeatedly, as shown by the dump truck there. So that wraps us up. The last question I have for you is, was this helpful? We'd like some feedback and like to know, did you find this webinar helpful? And did you learn something that you think you can put to use? And while you're filling that out, we just want to thank you for watching. Again, this will be recorded, so if you miss something, it'll be on our YouTube channel. For those of you that need to receive continuing education credit, we'll get you a certificate that you can self-report. Simply email us at info@rymarwaterworks.com. We're going to send you back a very short, very simple quiz just to verify that you stuck with us. And then we'll send you a certificate. And then also, we did offer a $10 Subway gift certificate. And so the best way for us to get that to you is via email. We'll send those out. So if you can email us at info@rymarwaterworks.com, we'll know you watched the webinar today. We had about 80 people attend, I think was our peak. We had 120 sign up. So we're happy to give the certificates out for Subway, but only to those that actually came in and watched with us. So please email us and let us know you watched, and we will get that out to you. We greatly appreciate your time. We hope you found it useful, and hopefully you will consider specifying the Marley float on your next project. And if I can ever be of assistance, please let me know. I'll be glad to do so. Again, my name's Jamie McCutcheon. My email is Jamie, Jamie, @rymarwaterworks.com. Please feel free to reach out at any time. Thank you so much.